In this video, we are going to study about the chemical properties of two important compounds, that is ethanol and ethanoic acid. We'll begin with ethanoic acid. Well, ethanoic acid being an acid will definitely react with a metal. So what happens when metal reacts with acid? So I've taken ethanoic acid. It's a weak acid, organic acid. If it reacts with metal, to give a product. Well, since it is a metal and acid, it will react to give salt. Well, salt is what? CH3COONA, sodium ethanoate, and then hydrogen gas is released during this reaction. Right. So hydrogen gas will be released during this reaction. So I'll be writing plus H2. This is plus H2. Now check here. As I said, we are talking about an acid here. So if it reacts with a base, let's say this time I take ethanoic acid CH3COOH. Now I'm going to react this with a base, say sodium hydroxide, and what I'm going to get, the same salt here. Whatever the salt formed here, the same salt will be formed, let's say. And the name of this salt is sodium ethanoate. Well, in this case, well, I said hydrogen gas. This was not H2O, hydrogen gas. And what do you know that an acid reacts with a base to give salt and water. So this time water is produced. Now the other property of ethanoic acid, it being an acid, will be what, like CH3COOH. If I react with a metal carbonate or say metal bicarbonate. So I take a metal carbonate, let's say I took sodium carbonate, Na2CO3, right? This is sodium carbonate. Let's make it a bit clear. This is Na2CO3. Now, what's again going to happen? Again, what do you know that the metal carbonate or metal bicarbonate reacts with acid to give what? Salt, water, and carbon dioxide. So this is going to be same. The salt is going to be same. The product so formed will be water plus carbon dioxide. And same will be true if I take a metal bicarbonate also. So I'm not writing. Instead of Na2CO3, if I take metal bicarbonate, say NaHCO3, the results are going to be same. The same products will be formed. Now here we talked about the properties of ethanoic acid based on it being an acid. So it will react with now we will review ethanoic acid, but let's say do few properties of ethanol now. We are going to do ethanol. First is its reaction with sodium metal. So if I take ethanol here, ethanol is what? C2H5OH, C2H5OH. When it reacts with sodium metal, we are going to get a compound called sodium ethoxide, right? This is C2H5. This is C2H5. Right, this H will be replaced with Na. So that's ONA. So this is called sodium ethoxide. And like in case of ethanoic acid, here too hydrogen gas would be is released. So this is important to understand that whenever you are asked to distinguish between ethanol, when you are asked to distinguish ethanol and ethanoic acid using chemical test, never give this reaction, right? Because you can see that sodium reacts both with ethanol as well as ethanoic acid to produce the same colorless hydrogen gas. As you know, this gas burns with pop sound. So you cannot say that we cannot use this test to distinguish between ethanol and ethanoic acid chemically. Now, coming to the next, we have dehydration reaction. So what happens when ethanol, that is C2H5OH, right? When it is heated at 443 Kelvin in the presence of a hot, highly concentrated sulfuric acid. You should write concentrated. I don't have space. H2 SO4, all right, CON. To give what? You see that as unsaturated hydrocarbon called ethene is formed. And besides this, water is released. So water is released here during this reaction. Well, since water is released during the reaction, we call this reaction as dehydration reaction. Right? The name only suggests here. And the dehydrating agent is what? H2SO4, concentrated sulfuric acid. The next is combustion should be easy because you know whenever a hydrocarbon, any hydrocarbon when it burns, whether it's an alcohol or any hydrocarbon or compounds of carbon, sorry, when it burns in the presence of oxygen, they produced what? Carbon dioxide, and this time is hydrogen and plus heat. So this is the next property of. Now what we are going to do, we have done the chemical properties of what? We have done chemical properties of ethanol, not all of them, if and we did chemical properties of ethanoic acid, and ethanol. And not what we are going to do is to some reaction which is involved both of them. Let's say ethanol first can be converted into ethanoic acid is what we are going to do. So ethanol is what? C2H5OH in the presence of it's KMNO4. That's alkaline KMNO4, right? KMNO4. That's alkaline or acidified K2Cr2O7 will give you what? Ethanoic acid, CH3COOH. So what you can see that here ethanol gets converted into ethanoic acid, and therefore important thing to observe here that here the oxygen is being added. So this is called also known as, it's an example of an oxidation reaction in which the ethanol gets converted into ethanoic acid, and these are the oxidizing agent. But it is necessary to write both of them, while any one of the used in the when the reaction takes place, you'll choose any one of these oxidizing agent. The two oxidizing agent here is alkaline KMNO4 or acidified K2Cr2O7. If it is not clear, I'll write once again. This is KMNO4, right? And this is alkaline. Okay, the above one is also not clear. This is K2Cr2O7, K2Cr2O7, but this is acidified. Now, another reaction that involves both of them, that is ethanol and ethanoic acid, is the esterification. So this is what I'm going to do here, esterification. So what I'll take here, I think I should remove this. I'll write ethanol first. So this is C2H5OH. When I react with ethanoic acid, that is CH3COOH in the presence of sulfuric acid to give a compound called ethyl ethanoate. And it's better if you write down the structure, ethyl ethanoate. First, I'll write down the molecular formula. Or should I write ethanoic acid? Let's say if I write its molecular formula, this is CH3COOC2H5. So this is ethyl ethanoate. So what is formed here? Ethyl ethanoate, which is an ester, right? And this is this ester is used as a flavoring agent. Now, reverse, similar, not exactly a reverse, but similar to a reverse reaction takes place. That's called saponification. Let's do that also. What I'm going to do, we'll take the esters so formed here. which is what? Which is C2, CH3, CH3, COO, C2H5. This ester, when it is reacted with a base, say sodium hydroxide. Now check what happens. Over here is H2O. This is H2O. When it is reacted with sodium hydroxide, what you will get? You'll get back the alcohol, C2H5OH, but you'll get the salt of this, sodium salt of ethanoic acid. Well, this is an example of a soap molecule. And since the product so formed is soap, that's why this reaction is also called saponification. So I can see that we can sum up with this much only, that these are the properties which we have to study in class 10th. The properties of ethanol, ethanoic acid. Yeah, but the important one that I missed is how to distinguish between ethanol and ethanoic acid chemically. Well, we have a litmus test, right? But using chemical reactions, how will you test it? As I said earlier also, that we shouldn't use this reaction with sodium, because both ethanol and ethanoic acid react with sodium to produce hydrogen gas. So instead, we should give the example of, like, if you are given ethanol and ethanoic acid, both are transparent liquid, and if you have to distinguish between them, then we use this test. Sorry, this one. That is reaction of, in both cases, we will add metal carbonate or metal bicarbonate. Best example will be sodium carbonate. So we'll add sodium carbonate in both of them, and you'll see that carbon dioxide gas is produced that will turn the lime water, milky due to the formation of calcium carbonate. Well, this will not, no change will take place here. No change or no reaction will take place. So we used, as I said, we use these reactions to distinguish between ethanol and ethanoic acid. In this video, we are going to study about two important reactions, that is addition and substitution reaction of hydrocarbons. Now let's begin with addition reaction. So what we say that in addition reaction, well, it is a reaction in which a substance is added to hydrocarbon and a single product is obtained in this reaction. So let's take an example. If I take, say, I took ethene here, which is an unsaturated hydrocarbon with a double bond between carbon-carbon atom. Now, if I add hydrogen to this in the presence of a catalyst, now normally it is nickel or palladium. See the result, what happens in this case. Here, the double bond between carbon-carbon atoms breaks and it accommodates to more hydrogen. So you can see from here that the reaction to more hydrogen is added. Look into this. So this is the product so formed. So here what happened, we have taken an unsaturated hydrocarbon, could be triple bond also, double or triple bond, and the atoms of different elements. I can take hydrogen, could be chlorine also, or could be bromine here. Right, they are added to this compound, and as in the presence of a catalyst, well, catalyst here I've taken is nickel or palladium. Right. So this is what. Now, this particular reaction has an application on it also. Like I replace this hydrogen, let's say I replace this hydrogen with alkyl group. Right. Say R is the letter we use for alkyl group. Now check here what is formed. Now, this is an unsaturated hydrocarbon. It converts into saturated hydrocarbon. But this particular reaction, we give an example for hydrogenation. So what is hydrogenation? It's a process in which the vegetable oil, right, let me show you the answer here. I've written the reaction in both ways. So you can see that here, the saturated hydrocarbon, that is, these are, sorry, unsaturated hydrocarbon like oil gets converted into saturated hydrocarbon, which say as ghee or vanaspati ghee or margarine, right? They are butter, right? These are the terms used here. So here the vegetable oils which is an unsaturated fatty acids, and which is, that is liquid at room temperature. They gets converted in the form of a solid, or we say it's ghee. Now, question arises that what about saturated hydrocarbon? So why do not saturated hydrocarbon undergoes addition reaction? So let's say if I take a saturated hydrocarbon, and if I react this saturated hydrocarbon with say hydrogen molecule only, or maybe say chlorine here. So you see that these carbon atom, you can figure out that carbon is tetravalent and it has all valency satisfied. There are no unsatisfied valency. Like there's no option for it being a double bond that can split into single bond. Right. So we say that this reaction, that is addition reaction, does not takes place in the saturated hydrocarbon. A very simple reason you can say that, because there is no unsatisfied valency in saturated hydrocarbons. So we can say that addition reaction does not takes place. In fact, this is the reason why we say saturated hydrocarbons are quite unreactive. And we can use this addition reaction. We can use addition reaction to figure out whether this is saturated or unsaturated. Well, bromine water test is more commonly used. This is bromine. Bromine water test is used. So bromine, which is actual color is reddish brown, in case of saturated hydrocarbon, right? In case of saturated hydrocarbon, no change in color will takes place. And in case of this unsaturated hydrocarbon, it will decolorize the unsaturated hydrocarbon, because you know that addition reaction takes place in unsaturated hydrocarbon. Now, but there is one more reaction, as I said, substitution in the beginning also. Substitution reaction can takes place. So let's study about this substitution reaction. So what happens that I'll take methane is also fine. I'll take methane. Well, you can see that it has single bond between carbon-carbon atom. Sorry, single throughout there's a single bond. So this is an example of saturated hydrocarbon, and we know that it is unreactive, right? And because of slow reactivity, it cannot undergo addition reaction. However, in the presence of sunlight, it can react with halogens. Well, chlorine is an example here, right? So it can react with chlorine readily, right? And what will be the result? You can figure out from the reaction that 3 of the hydrogen remains intact, but 1 hydrogen is replaced by chlorine. Another chlorine atom with this replaced hydrogen will form HCl, right? This is the product so far. So what you can figure out that this hydrogen is being replaced by chlorine, and that's why we say replaced by chlorine, and that's why we say it's a substitution reaction. One more time, this hydrogen, as you can see, is replaced by chlorine atom, and therefore we say it's a substitution reaction. But this is not very common, and as I told you that in the presence of sunlight, only the alkane takes place. Alkane reacts with chlorine, and such a reaction is called substitution reaction. Well, the question says a 3 ml of ethanol is taken in a test tube and warmed gently with water in a water bath. A 5% solution of alkaline potassium permanganate is added first drop by drop to this solution and then in excess. What we have to find out is to tell the role of alkaline potassium permanganate, which is a catalyst here. And the second is to write down the chemical reaction involved. So what I'll do first, I'll take the alcohol which is C2H5OH, and I'm going to heat this in the presence of what was that alkaline potassium permanganate. So this is ALK stands for alkaline, and potassium permanganate, right? That is KMnO4. But then there is an important thing also to remember. Besides this, there is another catalyst used, which is acidified potassium dichromate. that is K2Cr2O7. This is the another catalyst used here. And what is the result here? Result is ethanoic acid, CH3COOH, the product so formed. So now read the question. If I read the question again, we had to first find out, well, I have done the chemical reaction, and then they are asking you the role of potassium permanganate. So what you can observe that in the reactant, we have one oxygen, and in the product, there are two oxygen. Clearly, oxygen is added. Now, this is needless to say that this is an oxidation reaction. And if this is an oxidation reaction, then these two R should be considered as what? Oxidizing agent. These are oxidizing agent that is supplying oxygen. So this much we have to say, but you should remember that there are two catalysts. One is either of them is used, not both together, either acidified potassium dichromate or alkaline potassium permanganate. Now let's move to the next. In this question is why acetylene, also known as ethine, this is this burns with a sooty flame, right? It burns with a sooty flame, and that's the reason why while using for welding metal, we don't burn this fuel alone. This acetylene is mixed with what? Oxygen, right? Now, the reason for that, let's say if I take an example, not example, let's say I take down the molecular formula of acetylene or ethine, and if I take a saturated hydrocarbon, say with same number of carbon, that is ethene, C2H6. Check here, the percentage of carbon is 2 out of 4, which is how much? 50% of it is carbon and 50% hydrogen. Well, over here, what you can see, this is 2 out of 8. Here, the carbon percentage is 2 out of 8, that is 25. Yes, this is the reason here. As you can see that this ethine has higher percentage of carbon than hydrogen, and therefore many carbon particles does not burn here. And as you can see over here, it has lower percentage of carbon and higher percentage of hydrogen, and therefore there is no unburned carbon particle. So the fuel efficiency is high in this case. So we can see that the moral answer should be this only. That over here we will be saying that ethine with the molecular formula this, which is an unsaturated hydrocarbon, has a greater percentage of carbon content than hydrogen. And when it is burned in air only, not a mixture of air, a mixture of ethine and oxygen, it does not burn. The carbon particles does not burn completely. This unburned carbon particle is responsible for the sooty deposit, or we say a sooty flame or with smoke. But when it is burnt with, as you can see that lots of heat is produced, and you can just figure out that it is used for welding metal. In fact, melting metals must be large amount of heat is produced. Yes. So when it is burnt with a mixture of oxygen, it burns completely, right? All carbon particles burn, and therefore the heat is enough to weld a metal. Okay, now move to the next question.